ladies and gentlemen. My name is Afaq Ahmed. Welcome to the webinar on process-based auditing with risk-based approach to enhance the audit performance. In following slides, I'm going to share with you an audit tool that blends the process-based audit approach with the risk-based thinking to enhance audit effectiveness for high-risk audits in industries such as oil and gas, chemicals, and others. With that, let me share with you the outline of this presentation. First, I will very briefly review history of ISO 9001 standard revisions and their impact on auditing techniques, followed by step-by-step explanation of the audit tool that can be used to merge the process-based audit approach with the risk-based thinking. I will share this technique with you using two case studies, one from manufacturing and the other one from engineering, procurement, and construction industry. Lastly, a summary of the presentation. So let's begin with the background. The first publication of ISO 9000 family of standards came about in 1987. At that time, the present form of ISO 9001 standard consisted of three models for quality assurance. ISO 9001 for design, production, installation, and servicing, ISO 9002 for production, installation, and servicing, and 9003 for final inspection and test. The very first revision to the standard was made in 1994. At that time, minor changes were made to the standard. The ISO 9001-2000 revision resulted in major changes. The title was revised to ISO 9001 Quality Management System Requirements to shift the focus from merely a quality assurance model to a management system focused on achieving results. One of the most significant change was the introduction of system and process approach to quality management. The third revision to the standard in 2008 resulted in minor changes. As we all know, the 2015 revision has resulted in major change such as new structure, some new clauses, and preventive action has been replaced with risk-based thinking. These are just some of the highlights of changes. In short, the ISO 9001 standard, since its introduction in 1987 to date, has gone through a major transformation from being a quality assurance model to quality management system model with process-based and risk-based thinking in design, development, and improvement of the quality management system. This transformation has impacted the auditing techniques in a positive way. Prior to release of ISO 9001-2000 standard, most auditors followed the clause-by-clause approach. The process-based approach required to rethink how audits are planned and executed. After some time, most practitioners switched from clause-by-clause approach to the process-based approach of auditing. This concludes the discussion on historical changes to the ISO 9001 standard and its impact on auditing techniques. As we noted earlier, that the 2000 version of ISO 9001 introduced the process-based quality system approach. The present ISO 9001 standard employs both the process approach as well as the risk-based thinking in design, implementation, and improvement of the quality management system. Consequently, risk-based thinking needs to be incorporated in the process-based auditing technique. The question is how to do it. One way to do it is to follow steps required from the process-based approach and in addition examine process factor characteristics from risk perspective. Process factor characteristic is an attribute of process factor that is associated with risk. If left uncontrolled, it can cause the process to deviate from planned results. Let me walk you through the steps of the process-based and risk-based merger tool in coming slides. The tool consists of 7 steps. The first step is to study the high-level process map of the system and define the scope of the audit by selecting a process or group of processes. For a process audit, the scope may be a single process, and for a system audit, the scope may include all relevant processes of the organization. In step B, study the process flow of the selected process and identify an activity or group of activities for the audit. In step C, identify process factors. For example, the process shown on this slide, that is drive to work, some of the process factors for process element input are driver, automobile, and directions. In step D, identify process factor characteristics. As I said earlier, process factor characteristic is an attribute of the factor that is associated with risk. If left uncontrolled, it can cause the process to deviate from planned results. For example, on this slide, characteristics of factor driver are good vision, good driving record, and a sound state of mind. In step E, identify risk associated with process factor characteristic. In previous slide, process characteristics were identified as good vision, good driving record, and a sound state of mind. If these process characteristics are not controlled, then there is a high risk of accident. In step F, map the process factor characteristics to the requirements that we are auditing against. In this case study, it is requirements of the ISO 9001-2015 standard. In last step, G, develop audit questions around risk associated with process factor characteristics. Here are all 7 steps of the audit tool. First 4 steps are the usual steps that an auditor will follow for a process-based audit approach. Last 3 steps are the additional steps needed to integrate the risk-based thinking in the process-based audit approach. Together, these 7 steps form the tool that integrate the process-based audit approach with risk-based thinking. Let me explain the application of this tool using a case study of an engineered equipment steel fabrication shop. If you recall, step A was to study the process map of the system. So here is the high-level process map of a pressure vessels and tank manufacturer. It consists of a core process, that is engineering, production, packaging, and shipping. It also consists of supporting processes, for example, sales and marketing, procurement, human resources, quality, etc. Also, the step A requires to define the scope of the audit by selecting a process or group of processes of the system for the audit. As we know that not all processes of a quality management system represent the same level of risk in terms of the organization's ability to meet its objective. Some of them need more careful and formal planning and controls than the others. For example, product realization processes. Therefore, in this case study, the product realization process is selected to explain how the audit tool works. The step B requires to study the process flow of the selected process. So here are some major steps of the pressure vessel manufacturing process. The first step is receiving inspection, followed by storage. The first manufacturing step is cutting a steel sheet into required shape and sizes. Some of these cut pieces are rolled into cylindrical shells and welded at the seams. Several of these cylindrical shells are assembled and welded circumferentially to form the required length of the pressure vessel. After welding and completion of assembly, the pressure vessel goes through post-weld heat treatment, followed by several inspection and tests. Upon completion of inspection and tests, vessel is coated, and after final inspection, it is packaged and shipped to the customer. The step B also requires identifying an activity or group of activities for the audit. So here, the third activity of the process, that is cutting of steel sheet, is selected for the audit. Step C requires to identify factors related to process elements. For example, on this slide, factors associated with the process element input are cutting machine, operator, drawing, steel plate, and method of setting up and operating the machine. So far, we have completed steps A, B, and C as shown here. Step A required to study the process map of the system. Step B required to study the process flow and identify activity for the audit. And step C required to identify process factors. The next step D required to identify characteristics of factors, which are also shown here. For example, the characteristic associated with the factor machine is the machine condition. the characteristic associated with the factor, steel plate, is its quality, and so on. Same way, we can identify process factor characteristics for operator, method, and drawing. The next step E required to identify risk associated with process factor characteristics, which are also shown here. For example, risk associated with factor characteristic machine condition is that if the machine is not maintained adequately, then there is a risk of breakdown during production, which can delay the shipment of pressure vessel, and it can also lead to customer dissatisfaction. Similarly, risk associated with steel plate quality is that if it does not meet required engineering specification, then there is a risk that fabricated parts may be rejected. Similarly, we can also identify risks associated with process factor characteristics, operator, method, and drawing. Let's now complete the step F. Step F requires to map all characteristics of factors to the ISO 9001-2015 standard requirements. On this slide, in the top row of the table, I have identified risk requirements from ISO 9001 standards, which are 6.1.1 to identify risk, 6.1.2a to determine planned action to address risk, 9.1.3e to verify the effectiveness of planned action in addressing the risk, and 10.2.1e to update risk if planned action is not effective in addressing risk. In the first column, I have listed process factor characteristics identified in the last slide, which include condition of cutting machine, steel plate quality, and so on. Now let's complete the last step, that is, to develop audit questions around risks associated with process factor characteristic. So here are some questions around risk associated with machine condition. Is the risk associated with the machine condition determined? What is the planned action to address risk associated with the condition of machine? Is data on machine unplanned downtime analyzed and results of analysis used to evaluate the effectiveness of preventive maintenance of machine? Were there complaints raised due to unplanned downtime or late deliveries? If yes, was the risk updated? Similarly, questions can be developed around risk associated with the steel plate quality. Let's now do a similar exercise with activity number 5, that is welding. Steps A and B will remain the same as there's no change in the scope of the audit or the high-level process. Step C requires to identify factors related to process elements. For example, on this slide, process factors associated with the process element input are rolled shell, welder, welding machine, and welding procedure. This table shows a summary of completed steps A B, and C. The next step, D, requires to identify characteristics of factors which are also shown here. For example, the characteristic associated with the factor welding machine is the machine control. The characteristic associated with the factor welder is the welder qualification. The next step, E, required to identify risk associated with process factor characteristic. So, the risk associated with the process factor characteristic welding machine control is that if welding parameters are not controlled during welding, then it can result in defective welds. Similarly, risk associated with the welder qualification, availability of welding procedure, and others can also be identified. Let's now complete the step F. Step F requires to map all characteristics of factors to the ISO 9001 standard requirements. So on this slide, process factors identified in the last slide are mapped here in first column, which include welding machine control, welder qualification, and others. Now let's complete the last step, that is to develop a list of questions for the audit. So, audit questions may include, is the risk associated with the welding machine control determined? What is the planned action to address the risk associated with the welding machine control? Is weld rework data analyzed and results of analysis used to evaluate the control of welding parameters? Were there non-conformities due to defective welds? If yes, was the risk updated? Similarly, questions can be developed around risk associated with process factor characteristic welder qualification. This tool can also be used to identify interaction of processes and the associated risk when processes cross functional boundaries. Let me explain this in next slide. Here is the cutting step again, and one of the identified factor is the cutting machine, and one of its characteristic is its cutting capability. In this case study, the machine can only cut up to 3-inch thick steel sheet, which means pressure vessels of more than 3-inch thickness cannot be produced in this shop. This highlights a risk of accepting orders by sales and marketing of more than 3-inch thick pressure vessels. Clearly, the production process has an interaction with the sales and marketing process. The auditor made a mental note to check the risk of acceptance of orders of more than 3-inch thick vessels during the audit of the sales and marketing function. Let's take a look at the sales and marketing process flow. Here are the major steps of sales and marketing process flow. The process starts with receiving the inquiry, followed by inquiry review and submission of a quotation to the customer. If the order is received, it is reviewed and a confirmation is sent to the customer. Subsequently, the information is provided to the production planning for scheduling the order. The auditor did not find any controls in the inquiry review activity or the order review activity of the process to prevent acceptance of orders of more than 3 inches thick vessels. The risk identified by the auditor during the audit of the production process was cross-checked with the sales and marketing process, and preventive controls were identified to avoid acceptance of orders for over 3-inch thick vessels. This is a good example of determining risk associated with when process cross functional boundaries and identifying controls to mitigate its effect. Let's now apply this tool to second case study of a multinational engineering, procurement, and construction organization. If you recall, step A required to study the process map of the system. So here is a high-level process map of this organization. It consists of a core process, that is engineering, procurement, construction, and commissioning. In this case study, I have selected the procurement process to explain the two. The step B requires to study the process flow of the selected process. So here are some major steps of the procurement process. Step B also requires to identify an activity for the audit. In this case study, activity 4, that is, approval of suppliers by the supplier quality function, is selected for the audit. Step C requires to identify factors related to process elements. For example, on this slide, factors associated with the process element input includes the audit team capability, supplier evaluation and approval method, IT system, and so on. Completed steps A, B, and C are shown here. Step D requires to identify characteristic of factors, which are also shown here. For example, characteristic associated with the audit team is the audit team capability. Similarly, characteristic associated with other factors such as supplier evaluation and approval method can also be identified. Step E requires risk associated with the process factors. So the risk associated with process factor characteristic audit team capability is that if the audit team does not have required specific industry experience, then there is a risk that audit results may not be effective. Similarly, risk associated with other process factor characteristics, such as an availability of consistent supplier evaluation and approval method and others, can also be identified. Let's now complete the step F. Step F requires to map all characteristics of factors to the ISO 9001:2015 standard requirements. So the factor characteristics identified in the last slide are mapped here in the first column, which include capability of audit team, consistent supplier evaluation and approval method, and a reliable IT system. The last step is to develop audit questions around risk associated with process factor characteristics. Here is a list of questions that auditor may ask. Is the risk associated with the audit team capability to audit a specific industry determined? What is the planned action to address the risk associated with the audit team capability? Is the stakeholders' feedback analyzed and results of analysis used to evaluate the effectiveness of audit team selection method? Were there complaints raised on credibility of supplier approvals? If yes, was the risk updated? Similarly, questions around risk associated with other process factor characteristics such as availability of a consistent supplier selection and approval method can also be developed. Let me now sum up this presentation. As we noted earlier, that the 2000 version of ISO 9001 introduced the process-based quality system approach. Consequently, it brought greater prominence to the process-based auditing technique and practiced as a preferred audit approach. The present ISO 9001 standard employs both the process approach as well as the risk-based thinking in design, implementation, and improvement of the quality management system. While the process approach enables an organization to plan its processes and their interaction, the risk-based thinking enables an organization to determine the factors that could prevent processes and systems to achieve planned objectives and to put in place controls to mitigate its effects. Consequently, the process auditing technique also need to be supplemented with the risk-based thinking to meet the management expectation in enhancing the audit process and keeping it aligned with the transformation of the ISO 9001 standard. The tool described in this presentation blends the process auditing approach with the risk-based thinking to make audit process more effective for high-risk audits in industries, especially oil and gas, chemicals, and others. Using this tool, the auditor can carefully examine critical process factors, identify process factor characteristics, and risk associated with them. If these process factor characteristics are not controlled, then they cause the process to deviate from planned results. The tool can also be used to identify risks associated when processes cross functional boundaries. Armed with this knowledge of risk associated with process factor characteristics and risk associated with when processes cross functional boundaries, an auditor can identify preventive controls to minimize the negative effect on the process output. I want to thank all of you for listening to this webinar. Also, I want to thank the Exemplar Global for giving me the opportunity to participate in the Auditor Expo. Goodbye.